You may remember that in the topic of mechanics, we say that work is done when we apply a force on an object to move it by a certain distance. We have the equation mechanical work done is equal to force times distance. In a similar way, work done can be considered in a thermodynamic system. Let's look at an example where we trap a volume of gas in a cylinder, like a piston or a sealed syringe. If the gas expands to push the wall of the container, the gas does work. So this is a situation where work is done by the system. When work is done by the gas, the volume of the container increases such that the piston is moved by a certain distance. It seems like we can apply the work done equation here, as there must be a force pushing the piston out. But we do know that pressure is equal to force divided by area. Substituting this in, work done becomes pressure times area times distance. But the cross-sectional area of a cylinder times the distance is equivalent to its volume. So we end up with this equation. Work done is pressure times the change in volume of the gas in the cylinder. P is gas pressure, delta V is the increase in volume, W is work done by the gas. And in this case, work done is a positive value. But work can be done on the system if we compress the gas. The volume of the gas becomes smaller, so the change in volume is said to be negative. This gives us a value of work done that is also negative. The sign here is significant as it indicates work done on the system. If a gas undergoes a thermodynamic change at constant volume, the change in volume is zero. This makes work done in this equation zero. If you are given a graph of pressure against volume for an expanding or contracting gas, to figure out the amounts of work done in the process, all you need to do is to find the area underneath the graph.